Okay, hi and welcome to a set of video notes on graphing parabolas, but this time we're going to talk about factored form. And factored form in our little chart is going to be right here. Factored form really just means that you've factored, assuming it's factorable because we don't know how to complete the square, the quadratic. And you've got two linear factors that you can work with, maybe a coefficient up front. But that's what it's for. The great part about this one is that it reveals or shows x-intercepts super easy, which means that solving should be not necessary in many of our cases for this because it's already in a form where we get our x-intercepts. That's why we like the factor form. If we go back and revisit that we've seen the vertex form, remember that one reveals or shows the vertex really easily. So there's no reason to go find the vertex. It should be visible. So now that we're talking about factored form, let's talk about some of the stuff that we're going to do. Remember, we're trying to graph with features. So what are we going to do to this factored form so that we can find all the features we need to graph? Again, we will accompany in a moment here the video with, or pause the video so we can fill in a table and associate some of those features with the table as well. So let's talk though really quickly about how we're going to find these features to graph this parabola from this quadratic form. The first thing that you probably want to do, since they're staring at you in the face, is use the zero product property to set each of these linear factors equal to 0 and solve them. And then you'll have the zeros immediately. Once we have the zeros, we know that there's symmetry to these parabolas. And so if there's a couple of zeros on here, they're at the same y level, meaning that they're at the same height. They're symmetric. And that we can now identify where the vertex x coordinate is going to be, because in the middle of those, so if we find the direct middle of those zeros, that's going to be the h value of our vertex, or the x coordinate for it. Okay, so how do you do that? Well, you take both of the coordinates and you add them together and divide it by 2, essentially finding the average or the middle. So once we have the h value of the vertex, the next thing we're going to do is we're going to plug that into our function and evaluate the function at that x value. What's it going to do? It's going to tell us the y value so that we get the point hk from that. So it's going to give us k by evaluating the function at that coordinate for the vertex. And once we have that, now we have the vertex, which additionally, it got a little messy in here. Let me see if I can clean this up. Then that's going to give us the axis of symmetry, which will be x equal whatever the value of our x coordinate is. And then we're going to want to find the y-intercept, and we're going to want to find that by evaluating the function at 0. And that's going to give us our y-intercept. At that point, we should have enough stuff to graph if we do need to go get another point, so maybe evaluate for another point if necessary. Again, if we have 5 points after we do all that, then we're going to graph. All right. So at this part, go ahead and pause the video and fill in this table like we've done so that we can use it while we work. Okay, so you should have your table filled in. We'll come back to that as we go along, as we find some of our features. Let's go ahead and start finding some of these as we go. So first things first, we're going to check the direction of opening. Remember that the direction of opening comes from your a value. If it's positive, then you're going to open upward, and if it's a negative a, you're going to open downward. Okay, so looking at this, the a value doesn't seem to exist, which means that it's positive 1 there, so we're going to open upward. We can even draw a little image. We know it's going to look like that so far. All right, next thing that we're going to look at is not the axis of symmetry. We're going to go ahead and find the zeros. So to find the zeros, we're going to go ahead and use the zero product property from our two linear factors. So x plus 1 set equal to 0 and x minus 4 set equal to 0. Since I've used, we might be able to squeeze it in right here. So we're going to solve. So I'm going to take x plus 1. We don't need parentheses for that. And we're going to set it equal to 0, and we're going to take x minus 4 and set it equal to 0. So what we're going to find is that our x-intercepts are going to be at -1 and positive 4. So let's go ahead and write those in as x-intercept points. So we're going to have it as -1 and 0, and the point 4 and 0. All right, now that we have those, we're going to go back and attempt to find this vertex next. So what we need for the vertex is to find the middle of these 2 points. So let's graph them so we can kind of see visually what's going to happen here. So we know that there's going to be a point at -1, 0, and we should have one at 1, 2, 3, 4, 4, 0. So the middle of these, which you could probably speculate, 1, 2, 1, 2, and it looks like it's going to fall directly in the middle. So it looks like about 2.5 is where this vertex is going to fall in from either side. Actually 1, 2, 3, 4, 5. Yeah, so about 2.5 in from either side. So let's go ahead and calculate that though and see if we can figure out where this is going to be. So we're going to scoot down here to the bottom, and I'm going to take the x coordinates. I'm going to take 4 and I'm going to add it to -1. And I'm going to divide that by 2. So what I'm going to find is I'm going to have 3 divided by 2, or I'm going to have to go in 1.5 from each side for this vertex, or the x-coordinate of the vertex, shall I say. So with that, we really have, let me switch my color so I'm in the appropriate color, we're going to have the point, 1, 5. Now we've got to go back and find that y value, which is what we're going to do next. So to find that point, we're going to evaluate the function at 1.5 because it's going to tell us what y value would coordinate with it, and that'll give us our vertex. So we're going to plug that in. Our function then should be x plus 1, x minus 4. So I'm going to write that down first so I don't forget. All right, now we're going to do the evaluation part. So we're going to have 1.5 and plus 1. And we're going to have x 1.5 minus 4. Okay, and if we clean that up, we should find out that our function is going to give us -6.25. I borrowed that answer. You can run that quickly. So we're going to find out that our vertex is, let me scoot this over so we have enough room, -6.25, 1.5 and -6.25. So if we go down to our graph here, we're going to go to 1.5, which is what we speculated, right? That's also going to be our axis of symmetry right here, and we're going down 6.25. 1, 2, 3, 4, 5, 6 and a quarter. So right about there should be our vertex. Now we can get our axis of symmetry. So our axis of symmetry is just going to be our h value of our vertex, or our x coordinate. So we're going to say x equals 1.5. Let's go ahead and draw that in now. So we're going to have a purple dashed line that goes right down through here. So there's that. We've got 3 points. We could do a rough sketch, but we're going to go ahead and find that y-intercept and hope it gives us our 5th point. Now our y-intercept is going to come from plugging in the function at f of 0. So now we're going to evaluate the function at 0. So we're going to get 0 plus 1 times 0 minus 4, or we're going to get the value of 1 times -4, which is going to get -4. So our coordinate for our y-intercept will be 0, -4. So let's put that on our graph, 1, 2, 3, 4 down. And we'll notice that we're going to use symmetry here to get a point for free. So we are 1.5 away, so we'll go 1/2 and 1, and that should be where our y-intercept. That one was for free. We didn't have to work for that. That's nice. All right, so now that we have all those points, we should have enough to draw in our parabola. Remember, not V-shape, so we're going to do our best to round out of there and then go up through our points and kind of keep that pattern on that shape going up. Same thing on the left side. And we'll sketch that up. We'll shrink it a bit so that we can extend it all the way through the graph, or as close to the edge without getting into our work. All right, now we've graphed our parabola. We didn't even need to make a table, but if we look back at the table just to kind of correspond with some of the values, we'll notice that our y-intercept was one of the values that we did at 0, -4, nicely picked. And you'll notice that the symmetry of the vertex, look at where it runs through. You can see it right here. It's between these two -6's, or yeah, that makes sense. It's somewhere in the middle there. So that's where a vertex is, and that seems to fit what we found, right? Between 1 and 2, we said it was 1.5. It's right dead smack dab in the middle. Won't always be, but it was. So our vertex wasn't something we would see on our table. All right, so let's go ahead and identify our increasing and decreasing intervals. Increasing for this one's going to start at the vertex, and it's going up in y values on the right here. So that is our increasing segment. Our decreasing segment then is going to start somewhere over here at a negative infinity and work its way down, decreasing, y values are decreasing, all the way down to the vertex. So let's write those in. So we started by our increasing interval at our vertex. And remember, these are x values, so we're going to start at 1.5, and it's going to increase and include all the x values up through positive infinity, increasing from 1.5 all the way through infinity. And then it's going to decrease from negative infinity, somewhere over here, right? Decreasing as it comes down all the way in all the x values until it gets to this coordinate here, which again is our vertex at 1.5. Don't forget, this is a minimum. And the reason I bring that up is we're going to use it for range here in a minute. All right, end behavior then. With end behavior, we're going to be looking for the edges, or the ends of the function. In this case, we're going up on the left, and we're going up on the right. So when we get to end behavior, we're going to write as x goes to the left side, so as x goes to negative infinity, f of x, our y values, our function is going up to positive infinity, because that's what we saw in our arrows, right? Our arrows were going up, so the y values are going up as we go. So as x goes to positive infinity, which means to the right, f of x is also going up to positive infinity. All right, so we got our end behavior tallied. Domain again, right? We're all the way from negative infinity all the way to positive infinity, right? Domain is how far we can find it from left to right. So our domain, super easy, is going to be all real numbers. Our range, however, is going to include that minimum. So this y value right here, which was negative 6.25, is going to be our lowest point, and our highest point going up is going to be to positive infinity. So our range then, it's going to start with our lowest point, which is negative 6.25. It is included because it does touch it. It is the lowest point. We'll say y values then, all the way from negative 6.25 all the way to infinity. So there's our range. Something that we should address here is, can we put this back into standard form? And we did this in the first section of notes, but we haven't done it on this. So let's take a second and put this into standard form. So we're going to steal our function here. Right here, so we get f of x equals x plus 1 times the linear factor of x minus 4. To get this into standard form, we need to have x squared. It needs to be multiplied out. We need to see all the terms. So what we're going to do then is we will distribute. All right, so we're going to get x times x, or x squared, plus x times negative 4, or negative 4x, 1 times x plus x, and 1 times negative 4, or negative 4. Combining our linear-like terms here, we're going to get x squared minus 3x minus 4. Now you're like, why did we change it to standard form? Well, that depends on what they're going to ask us to do. So it's nice to know how to get there if we do need to. All right, so in this video, we've done a pretty good job of finding all of our features that we need to graph this without having to use our evaluation table. Again, we can see our y-intercept clearly. We can also see our vertex in there, but we were able to grab all of that information by one form or another and graph that function. All right, so you should be versed in how to graph, and we'll see you in class for a couple of examples.